Hello everyone, welcome back to the channel. This is Teacher Jeremiah and welcome back to the SMO Unlocked Step-by-Step Solution series. Today, we are looking at a very interesting topic on geometry, translation and reflection. So this question, you might notice that is not coming from SMO, it's actually coming from RMO. And some of you might be familiar. I have taken RMO before in primary school, teacher. But don't worry, this question is a very interesting question and the concepts that we'll learn today is something that you will learn in secondary math Olympiad. So it's one of the trickier questions in RMO and it might definitely even come up in SMO. So it's something we definitely need to look at. Let's have a look at the question. So this question is from round 1. Given that ABCD and DEFG are rectangles, FCG is 6 degrees, DAG is 35 and BE is equals to EF. Find angle AEB. So we have some information. Let's write it down. FCG is equals to 6 degrees. Okay. Perfect. And then DAG is 35. And BE is equals to EF. Interesting piece of information. We want to find angle AEB. So, right off the bat, after listing everything now, can we know any other information? Oh, some of you might have noticed we have a right angle triangle GAD. So, we can just find the remaining angle AGD, which is 55 degrees. Is that enough for us to solve for AB? Looks like we might be a bit stuck. So, first we know that FCG is 6 degrees and BE is equals to EF. This is a very interesting piece of information. When the question tells you that there are two lines that are equal, what shape can you think of? Some of you might be familiar. Hey, if we have two lines and we want to form a shape, then won't it form an isosceles triangle? So yes, if we have two lines, what else can we know about this shape? We know that these two base angles here are the same. So it will help us to find some angles in this question. So whenever a question tells you that there are two equal lines, then you must always think, can I form an isosceles triangle? Okay. And next, let's go back to the question again. We know this. But teacher, BE and CF, they are intersecting. How do I form an isosceles triangle? Here. Now, for these geometry questions, it looks like we might need to shift some of these lines. So, how do we shift it? First, we notice that to shift this, we want to make sure that the angles are the same so that we can use the information. But how do I shift it? Any ideas? To keep the angles the same. You notice, if I have two parallel lines here and I shift this line along the parallel lines, what can I say about the angle? It remains the same. It remains the same. So when you have and you want to shift a particular line so that you maintain the angle, you must always think of shifting it along parallel lines. We call this translation, which is keeping the angles. Okay. So now we have these two pieces of information. We can try and solve the question. Let's have a look. So now let's write back the information. Here I have 35 degrees, here I have 55 degrees, here I have 6 degrees. Perfect. And now we want to shift. How should we shift it? First, looks like we have the angle 6 degrees, which is FGC. Yes, FGC. FCG, sorry. And we need to try to maintain it. So looks like we need to shift this line FC. But remember, where should we shift it to? Some of you, remember, we have to create what? An isosceles triangle. So to maintain and create this isosceles triangle, I need to be able to make sure the lines connect at a certain point. Then you'll notice that I should shift line CF such that the point F now reaches the point E. So it looks like this. And I create a new point H below. And now I have these two lines are equal. And so if I want to create an isosceles triangle, what else do I need to do? Now I just have to connect BH and I draw another line. Wonderful. And what else do we know now? Since we have shifted this down along parallel lines, then this angle over here, it will also be 6 degrees. And any other information here? At this point, when we look at this new triangle, the isosceles triangle, it contains of some more shapes. Anything familiar with the rest of the figure? Some of you might have noticed that this triangle BCH looks awfully similar to ADG. But is it the same? First, let's have a look. we have the new line CH and in relation to any of the previous lines. Since the line CF shifts from point F to point E, and then point C, it will shift from C to H. So we can say that the two lengths, they are equal. So CH equals to EF. And we know that DGFG is a rectangle. So we can also say that it is equals to GD. Oh, so we know that CH is equals to GD. And next, we see that AD and ABCD is a rectangle. So AD equals to BC. And they have the two lines over here. And because we shift them, it's also 90 degrees. So we know that the two of them are the same triangles. Oh, now we can just copy the rest of the information here, which is CBH will also be 35 degrees. And this is also 55 degrees. So we notice that these two shapes are the exact same. And this is what we call a reflection. We see, it's basically I'm taking the top triangle, I'm flipping it around and I'm pasting it there. Copy paste, right? Just flip it around. And we call this translation, which is flipping a shape over a line, the shape remains the same. So now that we have all of these angles, we can try to solve for angle AB. Wonderful. What else? Since I know that BEH now is an isosceles triangle, then I know that angle EHB, I just need to sum it up, which is 55 plus 6 equals to 61 degrees. And if they are the same angles, then angle EBC, yes, it will share there's 61 degrees, angle EBH will also be 61 degrees. So I can just find the remaining EBC, 61 degrees minus 35 degrees. And I'll just get 26 degrees. Now that I have this, what do you notice? Oh, angle AEB and angle EBC, what's the relation? It is the same because ADBC is a rectangle and because alternate angles. So angle AEB is equals to angle EBC is equals to 26 degrees because of alternate angles. And we have solved this question. Wow. So this question is very interesting because it covers some very interesting properties when we try to solve these geometry questions. So let's recap one more time. Okay. First, whenever I have two equal lines or lines of two equal lengths, what must I think of creating? Isosceles triangles. Perfect. And to create these triangles, if I want to shift a line and maintain its angle, how should I shift it? I need to shift them along parallel lines, or known as translation. And last but not least, when I have two shapes and I'm just flipping it over, what happens? The shape remains the same. We call this reflection. And that's all we need to solve this question. So let's see if you master this question. We have a practice question over here. And if you have solved this question, you can type it down, the answer in the comment section below, or you can send it in our WhatsApp study group here as well. Or if you need any help, approach us in the group or contact me personally. Okay? If not, here's the answers for last week's question. Practice. And the answer is what? Simple 1. If not, I'll see you in the next video. Bye bye.